Now we might want to look at number 2, which asks for the matrix giving the number of 3-step walks in G. Now that's some more technical terms, but it's really not that much more complicated. Here I've copied down the adjacency matrix A again, and this tells you the number of direct connections or one-step connections from one circle to another circle. If I wanted to take 2 steps, say if I wanted to get from 4 to 3 in 2 steps, I could do that by going from 4 to 2, that's 1 step, and then from 2 to 3, that's 2 steps. That would be called a 2-step walk from 4 to 3. If I want to do a 3-step walk from 4 to 3, I could go from 4 to 1, 1 to 2, and then 2 to 3. So that's a 3-step walk from 4 to 3. This matrix will tell us the number of 3-step walks in G for every pair. So there are 2 3-step walks from 4 to 3. I could go 4 to 1 to 2, and then I could take the bottom or the top. So that's 2 different 3-step walks from 4 to 3. We don't want to sit here and count all the possible walks. We might miss something. And so there is a mathematical way to get this. If you have the adjacency matrix, A is the number of 1-step walks, right? It's the number of direct connections. There's this notion of matrix multiplication, and so we could talk about A to the 2nd power, which would be A times A. And that would be the number of 2-step walks. A to the 3rd power would be A times A times A, just like regular multiplication. And this would give you the number of 3-step walks. So we just have to do some multiplication here. A times A times A to get the number of 3-step walks, now that we already have A. So I want to do this multiplication, but first I want to do a more general example of what matrix multiplication is. So here I have 2 different matrices. These have nothing to do with A or G. These are just 2 matrices I wrote down. And I want to talk about how do we multiply matrices. So here we're multiplying this first matrix by this second matrix. You want to consider the rows of the first matrix and the columns, of the second matrix. So I'll look at the first row and the first column first. And the idea is the first thing in the first row goes with the first thing in the first column. 1 times -2. So 1 times -2 is -2. And then the second thing with the second thing. So 0 times 0. So I would do -2 plus 0. That's my first number in my answer. Then I'm going to move over to the next column. I'll stay in the first row and do the next column. So I'll look at 1 times 1. 0 times 3. So 0 times anything is 0. Still in the first row, move to the next column. 1 times 0. 0 times -1. You guessed it, first row, last column. 1 times 1/2 is 1/2. 0 times 0 is 0. So that fills in our first row of the answer. Match the row with the column and just move across the columns to fill in the whole first row of the answer. Now I'm ready to move to the second row of this matrix and also of our answer. So now I'm going to, instead of using the 1 and the 0, I'm using the 2 and the 3. So 2 times minus 2 is minus 4. 3 times 0 is 0. Now I move over. 2 times 1 is 2. 3 times 3 is 9. 2 times 0 is 0. 3 times negative 1 is negative 3. 2 times a half is 1. 3 times 0 is 0. And that fills in our second row. And finally, we get to the last row. So this will be the last row of our answer. If you feel comfortable with how this is working, try pausing the video and filling in the last row yourself. If you're not sure, or you want to check your answer, we get 0 times negative 2, which is 0. Minus 1 times 0, which is 0. Then I move to the next column, stay in the same row. 0 times 1 is 0. Negative 1 times 3 is negative 3. 0 times 0 is 0. Negative 1 times negative 1 is positive 1. 0 times a half is 0. Minus 1 times 0 is 0. So this is our answer for this multiplication of two matrices. We can simplify because we know how to add numbers. So just going to write down my final answer here. Negative 2 plus 0 is negative 2. 1 plus 0 is 1. 0 plus 0 is 0. A half plus 0 is a half. Negative 4 plus 0. 2 plus 9. 0 minus 3. 1 plus 0. 0 plus 0. 0 minus 3. 0 plus 1. And 0 plus 0. So here's our final answer for this practice problem. It should have the same number of rows as our original first matrix. That's 3 rows. And the same number of columns as our original second matrix, so 4 columns. So now that we've seen a practice problem with matrix multiplication, I need to multiply A times A times A, where A is our answer from number 1, in order to get our final answer for the next part of the Good Will Hunting problem. So our goal is to get the number of 3-step walks. That means I have to compute A to the 3rd power, or A times A times A. So I'm going to do A times A first, and then I'll take my answer from that and multiply by A. Just like if you're going to do, for example, 4 times 4 times 4, you would probably think about what 4 times 4 is first, 16, and then take 16 multiplied by 4 to get your final answer. So we're going to do the same thing here, but with matrices. So A times A first. That's getting us our 4 times 4, 16. So we want to compute A times A first. So now we're ready to compute A times A. Remember, we're going to do rows from this guy and columns from this guy. So start with the first row and the first copy of A. Remember, we're computing A times A. So this is our adjacency matrix from part 1. I'm going to write my answer down here so I have more space. I want to look at the first column first. 0 times 0 is 0. 1 times 1 is 1. 0 times 0 is 0. And 1 times 1 is 1. So first row, first column. We're ready to move over. First row, second column. 0 times 1 is 0. 1 times 0 is 0. 0 times 2 is 0. And 1 times 1 is 1. Next column. 0 times 0 is 0. 1 times 2 is 2. 0 times 0 is 0. And 1 times 0 is 0. And now we're ready for the last column. 0 times 1 is 0. 1 times 1 is 1. 0 times 0 is 0. And 1 times 0 is 0. So now we're finished with the whole first row. We went across each column with just the first row. I'll go step by step through one more row with you, and then probably cut to the end. So now we're focused on the second row, and we're ready to do each column. First column, we're looking at 1 times 0, which is 0. 0 times 1, which is 0. 2 times 0, which is 0. And 1 times 1, which is 1. Stay in the second row, but move to the second column. 1 times 1 is 1. 0 times 0 is 0. 2 times 2 is 4. And 1 times 1 is 1. Then in the third column, 1 times 0. 0 times 2. 2 times 2. And 2 times 0 and 1 times 0. And finally, the fourth column, 1 times 1, 0 times 1, 2 times 0, and 1 times 0. So now we'll jump ahead to the end of the multiplication. So here is our final answer for a times a, or a squared. And this means we're almost to the answer for this part of the problem. We need to multiply by a one more time to get a cubed. So pause here if you'd like to check your answer for a squared, and then when you hit play, you'll be fast forwarding to the answer for a cubed. So our final step is to multiply a squared by a to get a cubed. And so here I've copied in our answer for a squared and our answer for a, and we want to use rows and columns yet again. First row of a squared with the first column of a. So once you've completed the multiplication, we have here a cubed, which is a representation of the number of 3-step walks in G for each pair of vertices. So to bring this all back to where we started, each row corresponds to a vertex. So this is vertex 1, vertex 2, vertex 3, vertex 4. Each column also corresponds to the vertices in order. So vertex 1, vertex 2, vertex 3, and vertex 4. So this number 7 here should mean that from vertex 2, because we're in the second row, to vertex 4, because we're in the fourth column, there should be 7 different ways to get there using 3 steps. So if we go back to our graph, we should be able to get from 2 to 4 in 3 steps in 7 different ways. So I'll leave it to you to find all of them, but one example would be to go from 2 to 3 using this top edge, back to 2 using the bottom edge, and then up to 4 using this edge. So there should be 6 other ways to take 3 steps to go from 2 to 4. The magic of this is that this matrix tells us the answer without having to go through and try and count all of those. So that gives us the answers to part 1 and part 2, all having to do with matrices, which are very simple objects learned about in a sort of second year or third semester of a math major. And so the final 2 parts are a little bit more complicated, so I'm not going to go into all of the details like I did with parts 1 and 2. I just want to show you what these objects are, these generating functions. We won't go into all of the details of exactly how you would build them. I just want to show you what it looks like.